I am Nathan Keltner. This is Tim Elrod. We work for Fishnet Security. We're on our assessments practice team, meaning we do penetration tests and vulnerability assessments and social engineering engagements, all that kind of stuff. Let's see. So I'm from Tulsa, Oklahoma. My buddy here's from Oklahoma City, Oklahoma. He has a lot of previous experience with Blackhat DEF CON, founded the DEF CON group in the local area. This is my, let's see, my second year to Blackhat. It'll be my fourth year to DEF CON and some of the other conferences in the area. I'm a occasional developer for the Metasploit project. I've listed a couple of the ones up there that I've written. And
yes, Nathan made fun of me for putting my certs on our slide.
Yes, I took them back out. So you want to drive?
Okay, yeah. So just a little abstract about what we're going to talk about today. We're going to try to debunk some myths that we've kind of seen in the security industry about limited user post exploitation and why running as an admin may not, or running as not an admin may not be enough. Some people say that if you run as a limited user, you can mitigate large numbers of vulnerabilities from Microsoft, and we're kind of here to debunk that a little bit. We're going to talk a little bit about the limited user privilege model. We're going to exploit some user level privileges to do what we think is some cool stuff. We're going to talk a little bit about why admin access may not actually be what you want if you're doing a pen test or you're an attacker and you're trying to get data. We've got some examples and some demos, and that's about it.
Yeah, I just say at kind of a high level, the exercise that we started with was saying, so there's lots of talks here this week also. Go see all the talks about various different new privilege escalation stuff that's out there. I know there's some token kidnapping things that are going to be coming out. There's a lot of interesting stuff there. But we decided to say, well, what happens if you just ignore all that? Right? Let's say that everything's working like it's supposed to, and it's working as it's designed. Well, what can you do? Right? So without using any privilege escalation types of exploits or bugs, and focusing purely on the privilege model that we have, what can you access? Right? So we're not, anything that you see in this presentation is not necessarily something that can really be fixed. Right? It's not like it's some sort of zero-day bug that is allowing you to bypass some sort of model. It is the model itself. So really what we've done is we're going to go through, we'll talk about some of the different things that you can do. We've written a couple of tools to automate that process for us. As pen testers by trade, we will actually be using some of these things. I know I've got one coming up next month that is a highly restrictive, limited user environment that I will be using some of this stuff on. So hopefully it'll be useful.
Okay. So yeah, so again, reports published by some vendors that say, mitigating 90% of Windows vulnerabilities by running as a limited user, 80% of Windows vulnerabilities by running as a limited user. We're going to kind of talk to that a little bit. The main point here that you guys should come away with is exploitation of client-side bugs inside a limited user environment is still code execution. I'm still running code on your system. Regardless if you're a limited user or not, I'm still compromising your box. I still have access to all the data that you have access to. And again, yeah, they have access to everything that the user has. If the user can access a piece of data to do their job, I can access a piece of data to steal that data as them. And again, like Nathan said, while it's not the focus of this talk, if you guys want to talk about PrivEsc, there's 15 other Blackhat talks that do a really good job of that do better than what we would. So.
Okay, so just talking about the types of locations within the limited user model that you actually have access to, right? Obviously, the big obvious one is all of the local files and storage and things like that they have access to. Not really a lot to talk about there other than just kind of saying, well, duh, they can access their files that they use to do their job. Within the registry world, all of the local users' configuration items are stored in the HKCU, HK current user, and you have write update access to that. Obviously, configuration directories, there's sensitive files that are stored in there. Configuration files that will drive basically all the apps that they use. Those are oftentimes stored in user modifiable directories, so they can do things like save their permissions and save configuration options within the application. Sometimes you'll see some of that actually broken out and under, say, the program files directory, which would not be available for write. But there's still lots of stuff that's available within there that's interesting. You can access really the entire Win32 API. We're using that kind of heavily in some of our later code to do some fancy tricks underneath that. So the model still holds, right? So if you try to call a function that you don't have the access rights for, of course it'll error. But there's a lot of valuable functions that'll let you interact with the system. And then sort of something else just to think about. We're working on some code on this. We don't have it together for this talk, so we don't have a demo for it. But just as a general statement of how sort of the model works, right? You think about limited user blocking your ability to, for example, have update access or write access to program files in general. So system OS files, but more importantly, all of the applications that they run, right? That under a limited user model, outside of any sort of admin escalation thing, you don't have an ability to modify those executables on disk, right? Because they're in like some sort of protected directory that you can't access. But what happens, right? When the user runs that program, it copies all of that executable and loads all that stuff up into memory. And then they have update access to all of that memory. So while you can't actually modify it while it's on disk, you can make modifications on the fly and hot patch stuff. You can hook functions. You can do all kinds of things once it's up in memory, totally bypassing that particular restriction. Now, it's not persistent. You have to redo it every time the application launches via some sort of a helper object that's running in the background. But it's certainly doable. And then one of the things that we're going to focus on as sort of the biggest thing that we thought was interesting and that we really dug into and have some of our code working for later on is cache locations. So Internet Explorer cache locations, so the stuff that Internet Explorer actually renders potentially is coming off the local disk. So those cache locations, those files they're in user writable directories, and you can access them through various Win32 APIs. Obviously, as Internet Explorer needs to be able to access this stuff to be able to store caches, so we can also access it and do some interesting things.
So again, we have direct data access to anything the user has. Whether this be a database, whether it's a file, whether we're pivoting to another site or another machine inside the network that the user has access to, we have access to all that direct data access that they do. File shares, web applications. Web applications is kind of a big one with everything kind of moving to the web and SharePoint and things. We have direct access to that, and we can even have the user authenticate for us if we need them to. And obviously, we can take that data out of the environment. We have some indirect data access stuff. While data is kind of moving to things like controlled storage and like web apps like we were talking about, a lot of this is definitely built on the browser trust model. And so with the browser trust model, let's see how to put this. The Internet Explorer browser will trust a lot of things without verifying it. So it'll trust that the cache hasn't been tampered with, and things like that. It'll trust that, where it thinks it's getting DNS from, for instance, like some talks last year where it's getting DNS from is actually valid. And it does a lot of that too with caching functions and things like that we're going to play with.
Right. So with the world that we're all going to, with going back towards locking down user workstations, maybe virtualizing your entire desktop environment, and running underneath limited user modes where you can, and then pushing all of those services back up, cloud-based stuff or what have you, where it's all basically coming through Internet Explorer. So if you own Internet Explorer, you own that entire application stack that user is using, right? Oh, yeah.
Okay, so while we can't get direct access to, say, cached password hashes that are stored like in the SAM database on a local thing or in the registry, we can't access those as a limited user. But there are ways to get the user that we've compromised hash out of the machine and possibly do interesting things with it, maybe to pivot to another machine, maybe to access a web application, things like that. We can still get access to that user's hash. There's a lot of ways to do this. The way that we decided we were going to implement it was with IE automatic authentication. So in Internet Explorer, if there's a site in the local intranet zone and it requests authentication, Internet Explorer will go ahead and automatically authenticate for the user, passing an NTLM v2 hash. And so we can do some things once we've compromised the system to modify those registry keys to put a malicious site in the local intranet zone, and then fire off Internet Explorer silently to the user, and it will automatically authenticate and give us the hash, and then we can go put that in our favorite password hasher and crack it from there.
Yeah, and the impact of that varies a little bit across which OS. So there was a big change from XP to Vista, and so in Vista and 7, you'll only see the NTLM v2 hashes come back, which you can still crack with, say, like John the Ripper. It's a JTR, popular password cracking tool. We'll do that as part of our demo on this piece later. But if you happen to catch XP and it has not been deliberately hardened, which most XP environments haven't, out of the ones that I've seen, the vast majority of my clients are all still on XP, and of those, I only know of one that's really gone through and hardened this at this level. So for XP, you'll actually get the LMv2, I think, yeah. I'm saying this right. The LM hashes, basically, the important distinction there is that they are an older backwards compatibility hash that you can use rainbow tables on. So it's not quite the same as LM and NTLM hashes in the normal way you think of that. So there's been other talks in previous years about rainbow tables and how those work. This is the network-based version of that. So it's a little bit different. Basically what it means is that you can crack the first 7 characters of the password instantly, or virtually instantly, and then you have to brute force the rest of them. So if the password is 7 or less, obviously it's instant or virtually. And then if it's anything less than, say, 10, you're going to do it in just a matter of minutes. If it goes up 14, 15. Question?
I did have a question. Does your second control site emulate something like their
No, it just requests an NTLM auth.
Yeah, so there's a
HTTP headers.
www authorize header that basically says, I want you to authenticate to me. I think that's the right header.
Yeah.
But, and under the defaults of Internet Explorer for single sign-on purposes in a corporate environment, yes.
Mm-hmm.
Yes.
Yep.
Right.
Yes. So we also can do some things with proxies on the system where we can have the user basically auth for us. This is somewhat similar to like a pass the hash type attack where we can request a site on behalf of the user without them knowing. They will auth to it. We'll get the content back and be able to do anything we want to do with that data.
So it's sort of like a proxy, except in the normal sense of the word, except you're getting their authentication credentials to go for you.
So we're going to demo IE hash grab, which is a script that I wrote to do this. So hopefully our demo works here. Okay. So we just have a simple backtrack VM with a Metasploit handler set up here. We'll set one up. And then you can see what my module does is it will copy out a John the Ripper compatible file to /temp. And you can see we don't have one here. We don't have, it's called JTR file, so we don't have that right now. So go ahead and boot this up once it gets up.
And in all of the tools that we've written today, as post-exploitation modules, they're all just Meterpreter scripts. So we'll talk a little bit later about some new Meterpreter stuff that was just added in the last month called Railgun that gives you direct access to the Win32 API. It's very useful and what we've based a lot of our stuff on. This particular one doesn't use Railgun. It just uses the general Meterpreter API, which does things like give you the ability to launch commands, launch applications, modify file system, modify the registry, stuff like that.
So
I was just going to say, we did run into a couple of bugs, well, not necessarily bugs, but just interesting things when you're working through it, that while the limited user has access to the HKCU Hive, the registry Hive, they don't have access to HKLM. So depending on which way you access it will depend on whether or not you actually can. For example, we started going down this path trying to just run the reg command. It's just command line reg.exe, which it actually caches like the entire Hive first. So it'll try to load HKLM and it'll fail, and then the whole tool will fail. But yeah, we worked a way around it, and we were having similar issues with the Meterpreter registry API that allows you to just directly modify that stuff, probably for similar reasons. So we kind of hacked around it and got it. But
so yeah, this is pretty simple. Right now, you just run IE hash grab. The one that we're releasing will give you options on things like you'll pass the IP where you want it to come back to. But we got this working pretty late yesterday, so once you just get it run, it should give us a JTR file and temp. From here, we can just simple kind of show demo.
And so obviously the specific usefulness of this on Vista or 7 will depend on password complexity.
Yeah, and so this isn't a complex password. This is just kind of a demo, but you can see we got a JTR file off the system because what happened is when you run the script, it goes out, it modifies the registry. It'll add your attacker box into the registry as a local intranet zone. It will then launch Internet Explorer silently to the user, directing it to that, which will request auth. The user will pass its auth. It'll store those hashes in the correct format, and then you just run John the Ripper on the file that it stores it, and you get the password back. So the password for the user ID Riot is Riot. So
yeah, and just sort of as a comment on Meterpreter scripts, if you just don't know how familiar you all are with it. One of the things that we're doing through this is actually launching separate exploit and auxiliary modules in the background underneath Meterpreter. So you can programmatically control anything that's in the framework. So anything in the Metasploit framework you can control within a Meterpreter script. So this particular one leverages it's auxiliary server capture HTTP underscore NTLM. And so this is an HTTP server that all it does is any request that comes in, it will respond back and say, hey, I want you to auth to me, and I want you to use integrated auth. I want you to use Windows auth. I don't want you to use Kerberos or something like that. And then when that comes back, it'll bounce a challenge against it using a fixed challenge of 11223344556, et cetera, which makes it easier to crack if you get the LM version that you can use against rainbow tables. And then at the end of the day, it just outputs that data back out. Normally, it outputs it to the screen because we're inside, underneath the Meterpreter script. We don't actually have access, or you don't have direct access to it. Print statements don't just come out immediately. So we were debugging that a little bit and just set it aside. We'll get it before we release the code. But it just writes it to file, and then you're done.
So that's our demo. Yep.
Yeah, what's your question?
So this is for, if you're exploiting a limited user environment, more likely than not, it's going to be a client-side vulnerability, like an IE bug or an Adobe bug or something like that. So, right, yeah. So it's going to be, when your shell comes back, the user will be there, and we're on the shell. So
there's additional attack surface under some of the service accounts that would be interesting to look at. We did not look at it for this particular talk, but so like network service and some of those guys that, for example, SQL Server 2005 runs under. Those types of things are similar in that they're non-admin users, but they're not like domain users. So, okay, so just quickly talking about persistence, nothing really new here. One of the other things that we were thinking through when we went down this path was just to go through the exercise of say, well, when we have admin access, what are the types of things that we want to do, right? And those are things like access passwords, access password hashes, access data, and persistence. It's easier with admin. You're a little bit more restrictive in the ways that you can gain persistence, but you still have access to registry, entries that will automatically do startup, things like that. Let's see. Yeah, it's stuff that malware's been using for a long time. There's a lot of advanced ways you can do this under admin. There's a couple of tricks that we found that we can do under limited user, but nothing really that exciting to talk about. So just kind of as a statement, it still works the same way it always has.
You can still get persistence.
And you can still get persistence. Right.
Okay. So, a lot of times in pen tests, what I've come across is I may get local system on a box through say MS08067, but my real goal is to access data for this company, the sensitive data. More times than not, I have to use tokens and things like that to actually reduce my privileges down to a limited user. Most places that have that sensitive data won't give access to that data to, say, local system on an account or the local administrator on a server or things like that. And even if they do, if you're in a fairly locked down, monitored network, they may be looking for things like that. I know a network I ran, we looked for if like SQL admins are accessing data they shouldn't, things like that. But if you're a limited user, you really don't have to worry about that, because if I compromise the head of HR's laptop and I access the HR database as her, nobody really cares. Nobody seems the wiser. That's what she does every day as her job. So we can do that as attackers and not really raise any alarms. So that's why, you know, a lot of times maybe admin access isn't really what you want.
Okay, so just talking about real quickly, you know, how browsers work, right? They have the ability, or websites have the ability to say, I want you to cache data for me, so I don't have to do all these extra transfers, right? You'll see advice from, you know, web developers talking about the types of things that should be cached regularly and all the time. It helps with all kinds of latency and performance issues. Let's see. This got me thinking. I went to a talk at ShmooCon this last year, ShmooCon 2010, where Dragorn gave a talk on wireless security, where he talked about attacking this cache stuff. Basically, he was talking on open networks where you have the ability to interfere with data. You have the ability to interfere with things like cache headers and the content that gets stored. So he had a lot of interesting attacks where you could hop in the middle of a TCP session, set arbitrary cache headers, which allow you to cache for, say, forever, and then stick whatever content you want inside it. When we started thinking about this, we said, well, wait, we can do the exact same thing. And what does that really give you, right? In this case, we're talking about calling specific Win32 API functions. I guess you want to talk about.
Yeah. So in the Win32 API, there are basically two functions you need to cache an entry. They're both in wininet.dll. They're both exported. They're very easy to access with like what we did with Railgun or with some custom C code, any way you want to do it. But those are create URL cache entry A and commit URL cache entry A. The first one of those will give you a file handle back for a randomly named file in the Internet Explorer cache that Windows sets for you. You can fill that with your data, and then the last one will actually commit it to the cache database so that IE will use it. So here are basically the file prototypes for those, or the function prototypes. Basically with create, you just pass it a string name that you want to come back out, or that comes out as your file handle, and you say, hey, here's the URL I want, here's the size of the URL, here's the extension of the file, is it HTML, is it JavaScript, and it's just going to pass you a cache file back. And then once you modify that, you just submit it up with cache expiration times from commit URL, the URL name that you're caching, any header info, you have to have valid header info for it to cache, and then the file, and it will go ahead and cache that and put it in the IE cache for you. So since Vista, Internet Explorer has had two types of caches. They have a normal integrity level cache, and they have their low integrity level cache. So normally, IE will run with the low integrity level cache. The funny thing about this is the functions that we talked about previously work the same for either one. The only thing that matters is, are you in a low process already, a low integrity process already? And if you are, you can write to the low integrity cache. If you're not in a low process already, you can write to the normal cache. You can also do things like injecting your payload into, like once you get a shell, you can migrate into low process caches and things like that to access the low. IE will use the normal cache for trusted sites. So if you can put a site in the trusted sites list, it will actually use that normal cache for the trusted sites. For everything else, though, it uses the low. And it's fairly simple to get to that. We can set a low integrity process. We can migrate into that, or you can use a simple command line if you have, maybe you have a shell or a binary that you dropped on the system. Just a simple command line, ICACLS, set integrity level to low. We'll put your integrity for that binary into low, and then all the same code works the same. You just get low cache headers. So both of these techniques, either the trusted sites list or migrating into low, are supported by our tool. They're useful in different situations, and they'll be in the tool for you guys to use. So.
Sure. And just sort of to back up a little bit and talk about why we even ran down this pathway. And we started thinking about what you can do with the cache and why it's maybe interesting. And so the point that I made earlier about that really IE in most corporate environments is sort of the single point of attack, if you want to look at it that way, for all of the major applications that are in use. With this particular way of attacking a system, it's really pretty nasty. Because what happens at the end of the day, right? I can let's say I pop it via some Adobe bug or something similar, and now I'm sitting as a limited user. I can do this type of attack and then pull back off the system, and I'm gone, right? I have no code left on the system. I mean, I have no shells sitting around, but my cache JavaScript is going to sit there forever, right? As long as I've told it to. So at the end of the day, when you're thinking about the footprint left behind by an attacker and the types of things to look for to see if the system's compromised, I don't even really know how you would see this. Obviously, I mean, you can fingerprint our specific like stager code that we're using in JavaScript and some of that, and if you see that, flag it like, oh, somebody's using Metasploit on my network. But in any sort of real attack scenario, I don't even know how you would detect that this occurred. Because all you're going to notice is that off of some sort of magical baseline that doesn't exist, is that there are these cache entries that are maybe longer than you would have expected, and then they have, am I coming apart here?
Go ahead.
All right. So all you're going to see is cache entries that just have sort of weird, anomalous entries. But even then, how do you know that that's not what the website wanted, right? But at the end of the day, that code is going to be executing on top of any application that loads inside that browser. And through JavaScript, within that, right, you have access to everything. It's sort of, I mean, XSS is kind of lame, honestly, but in this case, it's like super XSS on any site, anywhere that user ever visits for all time, right? Until either their PC is rebuilt in most environments, like that's kind of the only time that's going to happen, or if there's somebody in this room, maybe you go in and you clear your cache from time to time, but nobody else does. So in, like I said, last month, new Meterpreter extension called Railgun gives direct access to the Win32 API through Meterpreter scripts. And then so through both that and the ability to launch exploit modules, you can now fully interact with the system and do all kinds of scary things. We extended this with WinINet DLL to add in the functions that we talked about earlier, and then we're interacting with a lot of other, the functions that are already there to do things like pull system time and then modify that time for the new cache stuff, and then convert it into the right format and all that. So by doing this, I can target individual sites as I want, or and we didn't we had some bugs in this and didn't get this particular piece ready for this demo. But you can also just read from the cache, right? You can read from the history and say, give me everything that this user goes to, right? I want to look at things like OWA, maybe SSL VPNs, things of that nature, where just sort of as an FYI, those sites will not actually do caching. So if you look at, say, Outlook Web Access in your IE browser cache, you won't see any entries for it. You'll see that it shows up in the history file, of course, but there's general advice, and actually like Burp Suite and a couple of the other website scanners will actually alert whenever you have HTTPS content that is being cached, because it's sort of a bad idea, because they don't want you to be caching down, say, a user's social security number or something inside the cache. But so none of those actually exist right now. So we had to come up with a way to say, for any given site that may or may not exist in the cache right now, how am I going to do this so that I can get my code to run on top of that site when I don't know what that site looks like, and I don't know what its content is because it's not in the browser, and get that to do that generically all the time? Yeah, okay. So here, I'm going to switch gears, and we'll actually walk through this demo, and then we'll probably walk through a little bit of the code, and then, let's see, that'll get close to wrapping us up. All right. Okay, so for this particular demo, all I'm doing is I'm going to basically modify the page that comes down to swap out form posts, and I'm going to swap out the action item to make it go to my controlled spot instead. We played with having on-submit JavaScript actions that will run your JavaScript whenever somebody actually submits a post. So in that case, you can do things like fire off all of their data for whatever they just posted out in a, like say, a 1x1 iframe or something along those lines that's invisible to them, and ferret that data back out to your sort of backend server. and then follow on to the original one so you don't lose the page and the user doesn't notice. Okay, so for this, I had to write just a simple HTTP dumpers. It's just an auxiliary mod that basically just records anything you send to it. It's just a simple way to say record any information you receive, right? Let's see here. Okay. So I'm just going to use just a simple exploit here. This is just a client-side social engineering exploit, just as a way to gain access to my VM here. That's fine. Oh, great. And my keys are not working. That's fantastic. Yeah, Control C, Control V, I got nothing. That's awesome. This work? No. Demo gods are not with me. Ah, there you go. Oh, that's awesome. It's like it's holding down a control key or something. Thank you, VirtualBox. Oh, fantastic. You got to be kidding me.
Yeah.
Yeah, all right. Okay, so this is, like I said, just simple Java signed applet, social engineering one. We use this one a lot in visible iframes. Exploits the ability for signed Java applets to run with the same user authority as the user. So yeah, we use this one in social engineering engagements all the time. So. Okay, so session open. Okay. Use Railgun. So right now it's loading the Railgun DLL, pushing that across the network, and loading that into the remote process. Let's see. We'll do right. Try login. I can't remember if this one has problems or not. And then, oh, I got to back out of this real quick. So background out of the interpreter session. Whoa.
Yeah,
whoops. I ran it and background it at the same time. So now I'll launch that HTTP grabber that will just sit there and listen and record anything that comes out. All right. Go back down into the interpreter session. Railgun's already loaded, so run. And pass it the capture URL, which is the where you want it to send data, and then the oh yeah, I've got it right here, and then the one that you want to poison. Okay. Right. So it caches two files for me. It caches a JavaScript entry that I've created, and then it caches my sort of web stager code on the other side. So when I go to this website now, it will actually load my code instead of the code off the website. And it should have happened so fast we didn't see it. And of course it didn't work.
Refresh.
exactly.
Okay.
Um,
Do the presenter one.
you want to do, what's that?
Do the presenter one.
If I can find that one again.
This is why people don't do live demos.
Right. Okay, so that site's loading. So there's some quirks right now with the type of file that comes back and whether the extension is HTML or HTML. There's a particular hierarchy that IE uses to determine whether or not it's going to use a given cache entry. And so there's a couple of bugs there that we're still working through. It works on some page contents and not others. Like it'll work on google.com every time. A couple of these different Blackhat logins were a little flaky, and sometimes they do it and sometimes they wouldn't. And so this particular one, I'm setting the cache entry to run or to last for 1 month. And the other thing that you'll notice is that you'll get these get last errors of 32. When you see that on the commit URL cache entry piece, that means that basically the browser is open and they're looking at that site. So it tried to write to this file, but it couldn't because that particular entry was locked. So you just run it again, and then it works. Shouldn't have to. And there it is. So now I've replaced the action item here for this demo to make it blatantly obvious. You can also do, like I said, you can do on submits, which will create that. But in this case, so now if I were to fill this thing out and hit create, it fires and it comes back to me. In a real attack, I would have set that up so that it was not obvious to the user and they were directed to the correct place and all that stuff. But on this side now, we got basically all of that stuff. So anything that was typed into any of those fields, I now have. I've got their usernames and passwords for whatever. In the case of, say, OWA, you can start getting access to actual files and things of that nature. Basically anything that they're submitting back up. And then additionally, obviously, so this is just one example, right? You've got access to the entire DOM. So you can do anything from keyloggers within JavaScript, on key press events, do that. Beef is one a tool that implements a lot of this stuff. Beef was broken for me recently on current versions of IE, so I don't know if it's currently being maintained, but as a proof of concept, it's all there. And
So yeah, that's it.
so yeah, so I'll dive into some of the code here, and then we'll have question time. Okay, so what we've got here is just cache entry functions that will reach out to the system, pull down the system time, right? Make modifications to it, add 1 month to it currently, and then spit it back out. We'll create, so here create URL cache entry. We're passing it the URL, the given extension, and then the length value of 256. Here's where we actually write the payload. So we'll open a file handle and we'll dump our contents down into that. Come down here and show you that. Here's the commit cache entry function that'll actually commit that entry. Go down to the, here we go. Yeah, so the HTTP stager. This was really the kind of the thing that I found kind of interesting, so I wanted to talk about it for a second. As far as a way to have generic HTML that will load the real site in the background, modify it, and then replace it. So it's very simple. All it is on this is just load my JavaScript file and then call a couple functions, right? I want you to poison the page, and then I want you to swap it out for the real one. Poison page will just reach out and pull down the same site that you're actually looking at, and then just append a question mark on the end. You've got to find a way to modify the request that gets sent so IE doesn't use its cache again, because it will otherwise. It'll actually just pull the same site and you'll get stuck, and it'll do that a couple of times and then stop. So what we found was that reliably you can always just tack a question mark on the end of it, and that will actually render as a different site in IE's view. but as far as the server is concerned, it's the same site, and so they'll send you the same content back. Here, just doing a search for basically, so while, as long as you're not getting an error on searching for new form fields, then go through, find the form field, find the action item. I set markers, on each side of wherever the action item is currently going. Swap it out with my payload being my site instead. You can also do the same trick with onSubmit and just use a different JavaScript object to do it. And you're done. The site's loaded. It looks completely, flawless to the end user, and you now have forever running your JavaScript on top of whatever page that they're going to. So.
Yeah, and after you're gone, that's still there. Your scripts still get run every time they go to that page, every time they go to OA, every time they go to their SSL VPN. As long as your cache is there, they still get your poison cache entry. You still get their data, even though you may not even have access to the box anymore. You still get the data.
So anything else?
So just kind of in concluding, while running as a limited user is definitely a strong security practice, we recommend it. I recommend it to all of my customers. As something you want to do. It's not a silver bullet. It doesn't mitigate every Windows vulnerability. It doesn't, stop attackers from accessing your data and things like that. But it is definitely something you want to use, and you want to monitor your networks. As always, remote code execution is pwn. So, anybody have any questions? Yep.
Yeah.
I don't know if I missed it, but we were talking about hot patching. I think
So with Railgun, you can basically do, in Railgun, and then the Meterpreter source itself has all these same tricks. Like Meterpreter, the way that it works is it will do reflective DLL injection into a remote process. So through normal Win32 API, you can do things like open up remote process space and inject code into it, and then make it do stuff. So Metasm is another piece that's inside Metasploit, a version of it, and that'll let you do things like compile assembly on the fly. So you can compile that on the fly and then push it off onto a remote site and then say fire it off. And so you can also do things like open that up and say modify function returns for example, one of the things that we played with was hooking all of your send and receive types of functions so that you can sort of get a application-specific network sniffer. Right? So network sniffers are another thing that don't work as limited users because you have to have the ability to shim the network card, basically, and so it requires real low-level access, requires system-level access. Doing this kind of thing, you can hook those functions and then just redirect it down to your code block that does whatever you want and then redirects back to the original function. So you can say, go ahead and just grab this buffer that you were going to send or this buffer that you just received, and I want you to write that to a file, and I'll pick it up later. I want you to go ahead and ferret it back over an HTTP request or whatever you want.
It's basically like remote hit tracing.
Yeah, but just using...
But you can do it remotely through Meterpreter.
Yeah, using Railgun and the Win32 API to do that remotely. Yep. So it's not trivial. I mean, we played with it. We'll have code for it, at some point. Didn't have it in time to get it up here, but it works. Yeah. So
it'll be checked into the tree.
Yeah. Yeah, this should I'll check all this in later this week. Most likely, as soon as we get a couple of the other just cleanup stuff, getting some options exposed, things like that.
Should all be in the dev trunk of Metasploit soon. So, anybody else have any questions? All right. Thanks, guys.
Oh yeah.
So.
Are there any other ways of getting cache passwords other than the registry trick?
Yeah, you can do a few things. Things like MBNS spoofing, for instance. You can spoof MBNS replies back to the local host for things that it may request that aren't necessarily directly in DNS.
It's ways to fool the OS into thinking that a remote site is trusted when it's not. So you can either do that through registry entries and saying this site is trusted because I'm explicitly telling you it is, like I'm dropping it in the trusted sites or internet zone, or you can do network layer tricks of so. The MBNS stuff was one we were running down as a backup when we weren't able to get the registry stuff working.
Yeah, we have some code for that. A friend of ours, a guy named Red Sand, wrote some code for that, so that we have some of that. Also, we want to thank a couple people that helped us with the talk. Red Sand helped, Stephen Morris, a couple other people, Patrick HVE for doing Railgun because it's awesome. That's about it.
Yeah.
Thanks, guys. Say what?